Hello everybody and welcome to another Houdini tutorial. My name is Kate. I'm a visual effects artist and today we'll be making a iceberg and doing a quick intro into flip tanks in Houdini. Now I had something else planned for this tutorial. As you notice, it's already all set up. Unfortunately, while I was filming, half of my video footage was lost, so I have to just walk through this with you. So I'll explain how I set this up. As I started out by creating, and I'll just turn off all these for now. I started out creating my lights. So my lighting over here, I created a nice box to put it in. It's really good if you need to tidy up your work interface. I've got a distant light that's blue. My intensity, my color for my environmental light is that. Rotated it slightly to get a better overall tone for my iceberg. And I have an ambient light. Then I started looking at footage of icebergs, and I'll bring some up right now just to show you what we're looking into. So the second thing after creating my lights, I went in and looked for reference. So as we can see, if we were to pull up something like this, we've got some really blue-white tones that range anywhere from a vibrant color to a more less saturated blues and whites. But we have a ton of white water splashing upwards underneath the waters. We've got some wonderful blues and whites, and it's splashing up a ton of white water. We can't really see too much waves here, but for some collapsing icebergs, if we were to take something like this into account, where we actually see the wave and the iceberg has collapsed from the bottom upwards, we do see less white water at the beginning and more of a wave at the start. So now that we have some reference, what I did was I focused on the iceberg first. But I found out in the process of doing this that it might be better just to create flip tank first instead of your iceberg. As when you create your dot nets, they might overlap and cause some trouble. So I don't recommend that route. I recommend creating your flip tank first, deciding on your particle separation and values, and then moving on to creating your actual iceberg. As you can see, I have an iceberg and another iceberg over here. These I created. They are not static objects, they are not colliding objects in the scene, they are just random stones about the scene. I got these rocks off of free3d.com. They're very good. I personally like the model kind of test for icebergs. It works really, really well. And all I did was imported the file 3 times, transformed it, and then merged them together to create some nice background reflective objects for our water, which when you're creating a flip tank, that's what you need. You need tons and tons of reflections to make your water look realistic. So that's what they are for. They're just for reflections and making the scene look better. So let's talk about the flip tank first. If we dive into the flip fluid, you can see there's a DOP import, and it imports the flip tank from the DOP network here. This is where it's importing our particle fluid simulation. As you can see, there's an attribute delete here in a file cache. These are optional. I like to sometimes, if my simulations are very heavy, to create a file cache and also delete attributes either before or after the cache, so when I have this turned on, my flip tank loads more successfully and it takes less time to load. It's one of the joys of creating a workflow that works for you. Use things to your advantage. So if we look at the flip tank, you have the option of saving it to disk and loading it from disk. Do it if you need to. Fluid compress, the only thing I really changed was the particle separation. If we look at our surface preview, you can tell that I changed the color a little bit. And what I did here, feel free to copy this, I'll skim through them. I didn't really change too much. Here, for the velocity range, I've changed it from 0 to 10, so you can factor as big as the amount of velocity as you want into your simulation. And you can change that right here. I've chosen these colors because sometimes when you're rendering these simulations, your velocity ramp affects the color of your fluid simulation when you're rendering. So I chose the colors that work best for me. So if we skim through it, and I'll let that load, after importing stuff from the .NET, is push the water outwards from where our iceberg is collapsing. So it's creating that nice little wave that we saw in our reference. And you can see where the highest velocity would be here, and the lowest velocities will be out here because the iceberg and velocities the velocities from the iceberg collapsing have not transferred over into those particles yet. If we look over here at a particle fluid surface, we can see something interesting has also started to happen. We see that it's created this mesh over all our particles to a point where we actually can see how thick our particles are in our simulation and where they are going and how it's going to look like as actual water. Now in this case, you may have seen like my particles are way too big. This is because my computer right now cannot handle smaller particle separations. I'm working with what I got. So once again, you cache it, and in the render, it will look the same as here on this side. So we'll go back to our DOP import, and we'll just turn that back on again. Now let's go back to our flip tank initial. We turn that on, we also see particles, but in this case, we want to keep it off. If we look in here, we see you have the option of merging collisions into our wave tank. You can also plug in ocean spectrums into here as well. But in this case, we're not doing that. In our wave tank, you have the option of oversampling, narrowing down the particle separation, and the size of your flip tank. If we zoom out, this is what it looks like. Now, one big issue I encountered while creating my flip tank is that you may notice you have a really big sim. Your water will sink, and it'll look like it was sinking through your bounding box and also your entire simulation itself. It will interact with your object, but in the end, it will look like the water is sinking. It's not staying where it is. In this case, you need to adjust the bounding box of your wave tank, and you choose the size and how deep it is. And usually that will help depending on the size of your particles. If your particles are too small and you have a big tank, you'll notice the sinking a lot more. Again, dependent on particle size as well. This is one of the other reasons why my particles are so thick right now, is because I don't want them sinking. And out here, it exports the initial particles and the initial fluid surface to where we want them to be. So if we turn that back on, I'm going to keep these all off for now. Here's just merging everything together. I wouldn't fool around with it too much. I've actually turned off this file cache for a reason. I don't really need it. So if you turn that back on, we have the happy ocean surface. And this is what it sort of looks like right now. I've turned off material simply so the viewport loads faster. And when you're building bigger simulations, sometimes it's easier just to turn off all the lights, keep the standard shading on, and just make sure your viewport, it loads quick. And that's always important. So let's look at the DOPNet. Inside the DOPNet, we'll touch on the static object later because that's importing the Iceberg. But we'll focus on the flip tank for now. In the flip tank, I've narrowed down my particle separation to 2.5. That's way too big still. And my particle radius scale, this would be the size of your chunks of water, is at a 0.9. Again, I would probably go smaller, but my computer currently cannot handle that. You can decide whether or not you want to close off the boundaries of your objects. You have guides, physical, collisions. I haven't really changed anything on the physical side because it's water. I'm not making jello or anything like that. So I've left everything as it is. Click on our flip tank. We have the option of looking through here and changing the sub-steps if you wanted your simulation to go faster. Inside here, I haven't changed too much. Particle motion, kind of kept everything the same, as it is water, and I'm not making jello or ketchup or mustard or anything like that that has a different viscosity. There you go. Narrow bands, distribution. Looks great so far. So now let's move on to our whitewater. Do not build your whitewater until after you've created your flip tank. It won't work. It requires a particle fluid source to create your whitewater. The easiest way to create a flip tank and a way to create a whitewater source is to use a particle fluids menu on top of your shelf tools. Unless you know what you're doing, I don't really recommend building a flip tank from scratch. So many things can go wrong, so all you need to do is just click it and add it to your scene. And the same goes for the whitewater. Click it and add it to your scene. So if we dive inside our whitewater source, you can see there's another cache. This is probably one of the most important nodes you will use for whitewater, as this is where you can edit your emission, the curvature, and the acceleration of your whitewater. And here is where it brings in the compressed fluid cache. So I haven't really changed much once again. If we go into our whitewater sim, we have our whitewater object, and I've just edited the bounce a little bit because I wanted to bounce across the water a little bit more. And I haven't really changed anything over here other than the visualization range. So I've decided to color the particles by depth, so the deeper they are in the water, the more grayish they're going to be, and the more they reach the surface, the more white they're going to be. Now, when you're building an iceberg, something to keep in mind is that if an iceberg is breaking from the bottom and it's forcing itself upwards, the white water is also going to form from the bottom and force itself upwards. So you're going to have this bubbling on the surface. It's going to force itself through the cracks of the pieces of your iceberg, which happened in my simulation. So in the whitewater solver, all I did was scale down the size. The voxel size kind of kept the same. And depth range, I edited a little bit. Emission amount, I changed a little bit. And my buoyancy by depth, this was what it looked like. Foam, pretty much the same. And advanced, looks good. So for our iceberg, this is where it gets a little bit complicated. I'm going to go back up here to our file, and this is where we're going to start. And I'm going to zoom out by pressing Space G in the viewport and zooming out to here. So if I look at my iceberg, this is what I have. I have my rocks that I used for reflections earlier, and I'll show you what I did. So here we go for building the iceberg section. What I did is I took these rocks and then I blasted them away down to 1. So as you can see, I only have 1 now. I have something turned on down here, so I'll just turn that off for now. And I'll also ghost all of the other objects so we can just focus on this one rock in particular. So I subdivided it and then I transformed it to the center of my simulation, which is at 0, 0. Because that's the easiest way to keep anything working correctly. Just keep it at 0, 0. I once again subdivided it a little bit more because I wasn't too happy with it. And I made sure all the normals looked good. After that, I file cached it because saving out your geo on this stage would be a good idea. I narrowed it down. You could probably only use 1 frame, but in this case I used start to end. And this is where I first added another null. This is where the fun part begins, because for null fractures, you could also use a material fracture, and you could also use an edge fracture as well. But in this case, Voronoi fracture worked great for me. So here is where I painted some values, where I wanted some points to shatter. Scattered those points, went to my Voronoi fracture, and this is what the exploded view of my iceberg looked like. I wanted really big pieces because when an iceberg breaks apart, it's not flaking. It just doesn't want to look flaky. You want big, bulky pieces. So that's what I wanted. For my Voronoi fracture, those are my settings. And then out it goes. So here we go, and just for simplicity's sake, I'll tidy up my workflow a little bit. Just a little bit, enough to look tidy, but also so I remember what I'm doing. So we'll just tidy it up a little bit. I will label this base of iceberg. Drag that back in, so when I close it, I can toss it away. There we go. Fun. So over here, I made it .NET, and I renamed it .NET Iceberg. Inside of it is the dynamics to make this crumble into the ground. Here I had to fool around a little bit with it because my iceberg had fun with me. Let me try and find my iceberg. There we go. Displaying the geometry is probably the first step to do anything. As you can see, I've created a really tiny ground plane just to keep it in place. I did that once again by going to my collisions, adding a ground plane, and then piping it into here, or manually doing it works too. But I just kind of placed it underneath my iceberg. I will display the proxy geometry, so it's just kind of sitting there, and it can just wobble back and forth and create some splashy motion, which is exactly what I wanted. So those are the physical stuff for it. I created a group. I don't really need this. You can turn it off. RBD solver. Didn't really edit that too much. And then I added gravity just to make it crumble a little bit. So I'll sim it out and I'll show you how it moves. So space G. And it crumbles like that. So in real time, this is how fast it's moving. Just sliding like that. Perfect. One thing you want to keep in mind when you're dealing with RBD objects and things that are colliding in with each other is to always look at, when you're colliding things, they don't always sense their own pieces. So you want to make sure the divisions inside the actual geometry are being used correctly. So you may apply all the forces you like and they may be perfect, but if your collisions don't look right, then you're going to want to edit them a little bit. So if we turn on a collision guide, you can see that Houdini, oh, this is ugly. There we go. You can see that Houdini has sensed where the pieces are, and they are all correct, and then look like they fit together. And as long as they look normal, it looks good for me. So my uniform divisions were 56. You could probably go higher, but in this case, it worked. Also, the higher your uniform divisions are, the longer the sim time as well, because it's calculating a more precise collision point. So finding one that works for you is probably the best. I then came over here, and this is where it gets fun. And I'm also going to create a little box over here that says out Iceberg for flip. And we'll just make sure that's inside our little boxy box. Cool. So this .NET is importing everything from our Iceberg thing over here. I then deleted some pieces and some attributes that I didn't really need. And then I added a null just in case I wanted to reference that geometry from that point in time. And then reduced some polygons, made sure my normals were working, and then I unwrapped this. Unwrapping it, I lowered the spacing a little bit, but the unwrap is essentially for when we texture our iceberg later on. So we'll sim this out, just so you can see it. If I turn on my texture here, you can see it. That works nice. I then made this smaller, because once again, I wanted more smaller objects. In this case, if you're doing something to scale or something physically accurate, you'd probably want to keep it the same size that it was, but in this case, I needed something smaller. Instead of scaling up my flip sim, I scaled down my geometry. Now this little node right here, oh, I should probably show you my transform settings. So that's what I made it look like. So now if we look at our trail, I've got this thing turned off, but in case you need it, I'll explain what it does. When you add a deforming or a static object into your flip sim, Houdini might decide that it's going to calculate the velocities the way it wants to. And in my case, I didn't have a really big splash. And I wanted a big splash. So what I did is I recomputed the velocity, and I cranked up the velocity scale to something that I really wanted. If you want a big splash, I would recommend adding this. If you want a little splash, slow your iceberg sim down. So I'll turn that off for now. I don't really need it. But this is where I created a static object from. So if we let that cook out, I'm going to cancel it and I'm going to go back to my first frame. I'm going to turn on my iceberg. You can see it's sitting right here. And if we go back to our .NET, my static object is grabbing that null and bringing it into here. So once again, I clicked Use Object Transform and Use Deforming Geometry. And I turned this off, and I made sure my collision radius and my collision guide were all looking correct. If it also doesn't look correct, you may have to crank it up. In this case, I added more uniform divisions, and that seemed to help everything. If I turn that off and go to bullet data, everything does also look correct. But that's where I added back in, and that's how the flip is calculating where to collide the water with my iceberg. You can also turn your iceberg into a volume and then add your volume into your water simulation so it calculates the water off the volume of the object. In this case, I didn't really want to do that. As you can see, most of my iceberg, half of it's underneath the water, so we can force that water upwards and we can get a nice wave going. So now let's go over to this mess over here. This is I wanted to add some extra kind of puffy particles that happened when my ice collapsed. So there's the white water that was coming off the water, but I also wanted some kind of flaky ice to be popping off of, I would say, the iceberg itself. So if we go up here, I've grabbed my iceberg, and I've deleted all the color attributes off of it. As you can see, it's grabbing the icebergs for particles, which I think I created over here. I don't think I need that, so I'll turn it off. But I then scattered points across my iceberg, and then I blasted some away. So those are our emission points for our particles and also our smoke. I then created a pop net, and if we dive inside of it, you can see that I've turned it to sourcing the points from the first context geometry. So if we sim that out, we can see something happen. So as you can see, I've created a particle sim. And I've also animated the constant activation. I've turned it off before 71, and then at 72 I've turned it on, and you can see the particles emitting straight upwards. And those are my particles coming off of my ice. So I'll sim that out. And I just wanted some debris to come off of my iceberg when it breaks up, especially towards the end when the pieces are floating in the water. So for the pop wind, these are the changes I made. But for the pop force, these are the changes. For the pop object, again, I wanted to use my object transform. I didn't change anything on the physical. These are my pop solver settings. And then I added some gravity, and that was basically the pops. And then I trailed the particles. I wanted to be big and bulky, so I trailed the particles, and I added a time shift. For the attribute randomize, I turned the P scale down to this, and then I grouped some of the particles. And the reason I did this is because I needed to delete the particles that would be inside my object. In this case, my iceberg. So I created a group, which is remove points, and then I deleted the points I was no longer using. This helped speed up my simulation. Then I copied a sphere to the points, and I cached everything from there. And that was the cache. And then deleted any attributes that I didn't need, which is pretty much everything at that point. And then for the attribute VOP, I decided this was a little bit too bulky, so then deleted some color. Then I added my VBD from polygons, and this is going to load a little bit slower, so we'll give it some time. The voxel size is that. Instead of using a fog, I decided on a distant surface, so that's what I used. I then converted that to a VBD, so I converted the SDF to a fog, and then I deleted any attributes that I didn't really need. And in this case, I didn't need to delete anything. I just had that there just in case I need to delete anything before the file cache. So if we go to our file cache, that's what it looks like. In this case, you don't need to worry about the particles being too pokey. We're adding a shader on top of that, which kind of smooths everything out. Volume VOP. Inside of this, I added some noise to the density, then I fitted it, and then I piped it back into the density itself. Then I transformed this downwards into our smaller iceberg, and I added a null. So now if we jump back out, I'm going to turn off my render iceberg, and I'm going to go back to my camera. Set the camera wherever you'd like it. It's up to a preference. And down here you may have noticed I've created some render nodes. And what I'm doing is I'm separating my iceberg from the mist, but I'm also keeping the white water and interior and the flip fluid activated over here, as well as the other icebergs. Inside here, all I've added is a simple object merge. So that is my pieces of my iceberg. And inside here is the mist for the iceberg. And this helped me attach the shaders onto my objects that I wanted. So if we turn those on, I can show you the settings. So I've added a principal shader onto the iceberg and a billowy smoke onto my mist. This principal shader here is also the same shader I used for the icebergs over here. I'm going to add some velocity blur to that, and the same goes with my smoke. Now if we test render this, we should get something iceberg-like. So here we go, this is our iceberg. So far so good, right? So if we go to our material palette, I'll show you the settings that I used to create this water, as well as the principal shader for the ice. I didn't do anything too complex because I felt like that would be a bit unnecessary in this case. So for the basic liquid, this is the shader for the flip tank fluid. For the flip tank interior, it's using a uniform volume shader. For the basic liquid, all I did was crank up the diffuse intensity, turn the base color to that. I didn't do too much for the displacement or the open LG. For the subsurface, these are the changes that I've made. Reflect, made sure it's reflecting objects and reflecting the lights in the scene. The more reflections on your water, the better, and the better result you're going to have. Refract, not too many things. Emission, I didn't really touch that. You can fake some things with emission, but in this case I didn't really want to. Opacity scale. Oh, let me turn. You can already see what happens when you crank down your opacity scale. So we're going to keep that at normal for now. If we go to our whitewater, these are my settings. For the uniform volume, these are also my settings. Billowy smoke, this is with the shader for our particles coming out of our iceberg. These are the settings. I didn't really touch the emission too much, but you could probably turn that off. For the principal shader for the iceberg, this is a little bit of a challenge because you're mimicking ice, but you're mimicking ice that is so big that it's not going to appear as if it's see-through, but it might also have snow on it. It might be a mixture of water that is just beginning to freeze or melting to ice that is completely frozen to snow. So it's a bunch of different water particles mixed together, probably with dirt or whatever's been in the ocean along with that iceberg. So you're trying to mimic something that's reflective enough in your water, but also something that looks like it's probably ice or something to do with water. So these are my basic colors. I had to crank up the dispersion so we would have our beautiful kind of rainbow, kind of eclectic reflection effect. And then edited the subsurface scattering and the sheen. I didn't really touch the opacity or the textures. I turned on the round edge radius. So already you can see our reflections from our iceberg. We have some lights in the scene. In this case, for this render, I turned on the overhead sky dome, simply because I wanted a background for this render, but this is pretty much what it looks like in the end. I'll pause it so we can skip ahead a few frames. So back to our simulation. Sorry, Houdini crashed on me and that was not fun. So as you can see, our whitewater is forming underneath our object, our iceberg is starting to break apart, and we can see some water splashing right there. If we go to our render view, we'll render that out and see what happens. So as you can see, the water is starting to splash up around our iceberg, and our iceberg cracks are starting to appear. If we zoom in right there, we can see one starting to render out right there. So that's pretty much it for building the iceberg simulation. I hope you enjoyed it. I'm sorry that it wasn't a node for node tutorial. I still hope you got some information from it, and I do hope you enjoyed it. My name is Kate, and I'll see you in the next video. Bye-bye!